this is Mrs. Murdock, and what I'm going to do today is I'm going to do a lab where I show the reaction of catalase in breaking down hydrogen peroxide into water and oxygen. If you can close in on that right there. You guys know that catalase is an example of an enzyme, and enzymes speed up chemical reactions. This particular chemical reaction is called the degradation of hydrogen peroxide. This is a different molecule than this, if you see. Water is very harmless, oxygen is very harmless. Hydrogen peroxide, though, if it builds up in cells, can be very harmful and toxic. So you have catalase enzymes in peroxisomes, which is an organelle you learned about in the last unit. And not just humans have these, but every living thing. In fact, from the earliest point in time, the catalase enzymes evolved early because hydrogen peroxide is a normal byproduct of digestion and metabolism. And once it appears, you need to have something to get rid of it quickly. So for example, you would find catalase even in something as primitive as yeast cells. You'd find them in there. And you would also find them in plant material like potatoes. If I cut up a potato, you'd find, this is my heart potato, I love this potato. But you would find it in potato matter, and you would find it in this lovely stuff. This is actually fresh chicken liver that I just bought this afternoon, so it's fresh. And it's very rich because liver, as you know, is an organ that has lots of, its main purpose is to detoxify. So it's very good. It has a lot of peroxisomes in the cells in there, so it's a very good source of catalase. And in fact, that is what we were going to be using. We are going to be using catalase enzyme that is now in here. That is from liver extract. I put some of that liver in the blender and I mixed it with cold water and sieved it out, and now we have our enzyme, catalase, right in there. Okay. The substrate that we're going to be using is hydrogen peroxide, which you can buy, at the store, and you probably have some at home right now. And you may even have noticed that if you use this on a wound, your own catalase enzymes in your flesh will interact with hydrogen peroxide and make those bubbles. And it is the bubbles that are actually oxygen gas, which are one of the products of the degradation of hydrogen peroxide. Okay, so we're going to do this lab step by step. This is not the lab that you're going to be doing in class with me. This is a slightly different lab, but because it gives some really good quantitative results, I wanted to walk you through it and use it as an example of how you can measure the exact rate of degradation of substrate by an enzyme in an enclosed environment. That's what we're doing. Okay, so the first thing I'm going to do is I'm going to make a baseline cup. I'm going to take 10 mils of my hydrogen peroxide. I'm going to pull it up right in here. And I'm going to put that in my first cup. And then I'm going to add, I'm going to use this kind of as a control. So at this point, I will be adding catalase enzyme, but since this is my control, I'm going to replace it with distilled water. So I'm just going to take a bit of distilled water and just put it in there and pretend that's enzyme. So that's my control. And then I would normally be swirling this and timing the reaction, but since we don't have any real enzyme in there, there is no reaction. So instead, I'm going to now add some sulfuric acid. Now, when there really is enzyme in there, think about what the sulfuric acid will do to the enzyme. This is pretty, it's 1 molar sulfuric acid, so it's not going to hurt me unless I get it on my skin and leave it there for a while, but it will definitely hurt the enzyme. It will cause denaturation of the enzyme. And we are using the sulfuric acid as a way of stopping the reaction, because since we know that it will denature the enzyme, once we do have enzymes in there, that will give us a way of exactly timing how much time the enzyme has in contact with the substrate. Okay, so right now, that's all together. Now I'm going to titrate this, but I'm only going to titrate 5 mils of it, so we're not here all day. Okay. All right, so I'm going to titrate this. Now this is potassium permanganate. It's a very bright purple substance, and I'm going to be titrating this cup by dripping. First of all, I'm starting with 0 mils. I already wrote that down at the top. And I'm going to keep adding purple to this until it stops disappearing. So now we need a real close-up of this, if we can. And titration means we are using a known amount of a reactant to detect an unknown amount of a different reactant. Come on. Whoop. And you see it's still clear. It's still going clear, right? So the moment it doesn't go clear, I'm going to stop it. I love these pipettes. There, see how it keeps going clear? This is just helping me to detect how much hydrogen peroxide there is already in the cup before I ever add enzyme. That's what this is doing. So I'm getting a baseline to give me an idea with the other cups of you know, how much the enzyme degrades per unit of time. Not quite there. Usually